In this presentation, we will explore the electronic structures of chemical elements. Electrons are a type of subatomic particles which are negatively charged and orbit around the nucleus. However, their arrangement around the nucleus is not completely random. They occupy energy levels or shells. Then the question that we shall ask is, how do these electrons fill their energy levels? You will answer this question with the following activity. So observe how energy levels or shells up to the third energy level are present at different distances from the nucleus of the atom according to Bohr's model of the structure of an atom. The lowest energy level is the one found nearest to the nucleus and is filled first. Then with additional electrons we move towards higher energy levels, thus moving farther away from the nucleus. The following table presents the arrangement of electrons in the first three energy levels or shells. The first energy level, which is the nearest to the nucleus, can hold a maximum of 2 electrons only. Then no more than 2 electrons are placed in this shell. Additional electrons are then placed in the second energy level, which can hold up to 8 electrons, where further additional electrons are consecutively filled in the third energy level, which holds up to 8 electrons too. So as you can see in the following simulation, the first energy level holds 2 electrons only. Then additional electrons are placed in the second energy level until being filled with 8 electrons. And lastly, additional electrons are placed in the third energy level until reaching its maximum capacity of 8 electrons too. These energy levels are filled with electrons starting with the lowest energy level known as the innermost shell, then consecutively proceeding outwards. Now pay attention. To start filling a higher energy level, the previous lower energy level should be full of maximum capacity. So let's say we have only 1 electron in the first energy level, then we cannot start filling the next level before filling the first innermost shell with 2 electrons, after which we can move on filling the second higher energy level with the available electrons. Now let's go over some examples to strengthen our understanding of the concept of the electronic structure of the atom and the involved energy levels or shells. In the following figure, we observe 3 different atoms, which are helium, oxygen, and chlorine. The atomic number of helium, which is the second element in the periodic table, is 2. Thus, it has 2 electrons as a neutral atom. So we should start filling the first innermost energy level, which can contain the 2 available electrons in helium. Next, examining oxygen, it has 8 total electrons. Then the first 2 electrons are placed in the first energy level, which is the maximum that this level can contain, and the remaining 6 are placed in the second energy level, which can hold up to 8 electrons. Chlorine in turn has 17 electrons, so following our previous approach, the first innermost shell holds a maximum of 2 electrons. The second energy level holds a maximum of 8 electrons. Thus, we have a total of 10 electrons in shells 1 and 2. Finally, the remaining 7 electrons are placed in the third and outermost energy level, which can hold up to 8 electrons. Now let's go over the first 20 elements in the periodic table and check their electron configuration. So let's start with hydrogen. The atomic number of hydrogen is 1, so as a neutral atom it has 1 electron in its electron cloud. Then this electron will be placed in the first energy level. Next we examine helium. It has 2 electrons where both of its electrons fill the first energy level. Now check lithium, where 2 electrons fill the total capacity of the first energy shell, which is 2, and the third electron is placed in the second shell. Next is beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So the atomic number of neon is 10. Then it has 10 total electrons. The first 2 electrons are placed in the first energy level, thus reaching its maximum capacity. Then we move to the next energy level with a capacity of 8 electrons, so we place 8 electrons in the next energy level, thus reaching a total of 10 electrons. With 10 total electrons, the second energy level is full. Then in the case of any additional electrons, the electrons are consecutively placed in the third energy level, which is the case of sodium with 11 total electrons, 2 in the first, 8 in the second, and the 11th electron in the third and outermost shell. Next, check magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon. Now pay attention that argon has the first 3 energy levels full, with 2 electrons in the first energy level, 8 in the second, and 8 in the third outermost energy level. Argon is another special element with 18 total electrons and 8 electrons filling the outermost shell, number 3. Potassium next with total 19 electrons and with its additional 19th electron placed in shell number 4, its outermost shell. And finally we examine calcium with 20 total electrons where the 19th and the 20th electron are placed in shell number 4. So by now you shall be able to exercise filling the energy levels of these elements where you may come back and check your answers at any time. Moreover, we can represent the arrangement of electrons in an atom using a shorthand which is called the electronic structure or the electronic configuration. This way, we show the number of electrons in each energy level starting with the lowest level and upwards. Then for helium, we write 2 since it has 2 electrons only present in the first and lowest energy level. Let's check the carbon atom. With an atomic number of 6, thus having 6 electrons, 2 electrons are held in the first innermost energy level. Then we can start writing the electron configuration of carbon as follows. We write down 2, followed by a comma. Then the remaining electrons are 4, which is the difference between 6 and 2. So obviously we write down 4 after the comma in the electron configuration, since the remaining electrons occupy the second energy level of the carbon atom after the one which holds 2 electrons. So the electronic configuration of carbon is thus 2, 4. Sodium in turn has an atomic number of 11 and thus has 11 electrons. Then we write down the electronic configuration of sodium as follows. The first energy level can hold up to 2 electrons only, then we write down 2 followed by a comma. The second energy level holds a maximum of 8 electrons, then we write down 8, also followed by a comma. And finally, as you have already noticed, the remaining electron is placed in the third and outermost energy level, thus we write down 1. Therefore, the electron configuration of sodium becomes 2, 8, 1, which represents 3 energy levels. The first occupied by 2 electrons, the second is occupied by 8 electrons, and the third and outermost energy level is occupied by only 1 electron.